All right, so yeah, my name is Musa Abdulkarim, popularly known as Wise Mr. Musa, and I'm going to be the instructor for today's class. Yeah. So in today's class, we are going to be talking about um, we are not talking actually, we are going to be learning about the Cairo programming language. So for today's session, we are going to be going through the first part of it. So yeah, we in order for us to so there are some things that we actually need to understand as regards Cairo so that it's going to like be a fundamental for what we are doing. So this particular class now is called the Cairo Master Class. And before you can have a master class in any session, it means that you have to be first good at the basis. So we all know that the reason we are learning Cairo is because we want to be able to build on StackNet. And uh, we all know that the reason we have StackNet is because there is a fundamental problem with distributed systems. So when you have a blockchain, so we have what we call the blockchain trilemma, which is that a blockchain cannot be decentralized, have security, and also scaling. So which means that any blockchain that you look at, they are going to sacrifice two to get the third one. They would have to sacrifice two in order for them uh, to get the third one. So uh, for Ethereum as a layer, so that's the reason we have what we call the layer one blockchains and then the layer two blockchains. So the layer two blockchains are basically solving the scalability problem. So I don't want to like dive too much into all of those talks. I believe the previous class has explained it better. So just a little bit of reminder uh, to serve as an introduction to what we are going to be doing today. Like why do we need to learn Cairo since we already know Solidity? Why do we still have to learn Cairo? Sorry, I want to add. So why do we have to learn Cairo? So that's the basic question. Now, so if you look at Ethereum as a layer one blockchain, Ethereum is decentralized, right? Yes or yes? Please, this is a chat. Like you can turn on your mic so that we can be listening to ourselves. Yeah. So it's not something very 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 serious like that. So Ethereum is a layer one blockchain. So and it is decentralized. Yes or yes?
Yes.
Yes.
Okay. So what do you mean by the word decentralization? So decentralization simply means that we have it can be in two things. Either it is centralized or decentralized. So when you say that something is centralized, it means that it is controlled at the center. Please, if you know that you are in a noisy environment, you can just be, muting or muting your mic when you want to speak, right? So you can. I'm trying to join the. Okay. That's, All right, so we have what we call, you can have something that is central or it is decentralized. So central, it means that it is controlled by one party. So when something is controlled by one party, it means that it is a central. So for example, when you hear the word the Central Bank of Nigeria, right? So Central Bank of Nigeria is a one party that controls all the financial systems that is happening in Nigeria. So all of us, we have no information about it. But when you say that something is decentralized, it means that you have a lot of things, a lot of authority, like a lot, all the entities, they are authorities in themselves. So, and when you have a decentralized authority like that, then there has to be a consensus mechanism. There has to be a way for them to agree to a valid state. So, and in order for them to, do all of those things, there are some trade-offs that comes into play. So we all agree that Ethereum is what is decentralized. The second is that security. The second is security. So Ethereum is also secured in the sense that, and what Ethereum uses as its security mechanism is basically, we have the crypto economics. So which is that when you want to, when you are, if you want to like hack Ethereum, then you have if you want to act as a dishonest party, so you have proof of stake, which a part of your like a large sum of money. So because of that, you don't want to try that. So but then scalability. So is Ethereum, is it scalable? So the short answer is no, because the for Ethereum, the number of transactions that you can have per second is between 15 to 30 transactions per second, which is very, very low. So in order for you to solve this problem, solutions. And for layer two solutions, there are basically two types of layer two solutions. So we have the optimistic roll up and the what we call the validity roll up. So when you say that something is optimistic, in English, optimistic is that you just trust that let's just be optimistic that these transactions are valid. And the way it also works is that if the transactions there is a context if a particular transaction is not valid. So which means that so far as nobody contests that a particular transaction there is invalid for the waiting room, then the transaction is valid. So that's the optimistic. You are optimistic that all the transactions there are valid. So the validity roll-up, that one is also called the ZK roll-up, which is the zero knowledge, which means that when you are bundling a transaction, you are also sending its proof, the proof that this transaction is valid. You are sending it along. So, and there are many ways in which you can have the ZK. So we have the ZK Prometheus that talks about all of the different ZK systems that we have. So talking about the circuits, the R1CS, the rank one, we have the rank one constraint system, the quadratic arithmetic program, and then we now have another one that you can now also use to prove that a particular transaction is valid. So the ZK, we now have what we call the snacks and the stack. So when you have stack and snack, we know what snacks means. Snacks means something non-interactive argument of knowledge, while stack means scalable, transparent argument of knowledge. So when you have this now for stack, if you want to prove something here, so you have to first convert those statements, you have to convert what you want to prove into arithmetics. So you have to convert it into arithmetics that you can easily prove. So the process of converting whatever you want to prove to arithmetic is what we call what the arithmetization. So we have the arithmetization process, and there are different arithmetization processes. So one of the arithmetization processes that the rank one constraint system is an arithmetization process. So you are converting everything into rank one is that you can have x plus y equals to z, or x times y equals to z. You can prove the two. And you also have the quadratic arithmetic program. So we also now have the third one, which is what we call the what. So in this, for Cairo, for StackNet, what is now used is we now have something we call what the so we have what we call what the Cairo. So what is the meaning of Cairo? So Cairo simply means CPU algebraic intermediate representation. So CPU algebraic intermediate representation. That's the simple meaning of Cairo. Sorry. So that's the simple meaning of Cairo. CPU algebraic intermediate representation. So what does this mean? Now you know that when you are performing a program, when you have a computer, right? Now a computer is simply we have a general a computer is just something that makes our work easier. It takes in input and gives us output. Now the CPU of a computer, normally before you used to have CPU or chips. Let's call them chips that are designed for a specific purpose. So if you want, you can design a chip that is going to, just take two numbers and produce another one. So, but then we had Alan Turing that gave a model of a general purpose computation, which we call the Turing completeness. So with that, you can have a single. No. That's the von Neumann architecture. So the von Neumann architecture is the one that proposed a system whereby you can have a general purpose computing. So a general purpose computing means that you'll be able to like compute, program anything on the CPU. So we have CPU model. So this particular one also is going to be one of CPU models that you can make use of. So what does this CPU model do? So it's simply a way of converting. If you have if you have sorry yeah. So if you have any computation, it's going to you are going to be able to use this particular architecture to be able to process it. You'll be able to use this particular what's it called, to be able to process it. So now this Cairo, the Cairo that we are now talking about, we need to understand that Cairo can mean two things. Cairo can mean two things. So Cairo itself, so there is the Cairo that deals from the low level to the execution of proof systems. So, and that one, it's simply that when you write algebraic representation, you are going to write whatever you want to prove. It allows you to be able to like generate prove a computation. You are going to generate proof of computation, and you are going to verify it in a computer that has a smaller power. So when you have Cairo in that case, so when you write, let's say you can write your algebraic representations. You can write your algebraic representations, and that Cairo is going to help you to prove it. So that's like one aspect of Cairo that we need to firstly understand. So that's the reason. So that's like the first part of Cairo. Then we now have another part of Cairo. So the other part of Cairo is the Cairo programming language itself. So the Cairo programming language now allows you to write, it now allows, it compiles an high-level programming language into uh, the Cairo assembly. So if you look at the way the evolution of StackNet and the Cairo, there was a time that we had the Cairo 0. So in Cairo 0, it was a Python that you can simply use to write uh, to write to write all those intermediate your program, and it's going to be converted to what, to Kazim. Then from Cairo 0, it moved towards to Cairo 1. So in Cairo 1, we now have this one. It was Python, and this one, it is Rust-like uh, programming language. So, which means that this is like a layer of abstraction, which gives us, we don't want to think about x plus y equals to 3, x plus, we don't want to think about all of those low level stuff. So we have the Cairo programming language that is going to allow us to write a smart contract in a syntax of a friendly programming language like Rust, and is going to compile it down. So when it was in Cairo 0, when you write your Cairo 0 program, it's going to convert to what? To Kazim. But for Cairo 1, when you write a Cairo program, when you write a Cairo 1 program, it's going to convert it to what we call what? Sierra. It's going to convert it to Sierra. What does Sierra mean? Sierra means save intermediate representation. Save intermediate representation. Now, this Sierra that you now have will now be converted to what? To Kazim. Now, if we are going to ask, why do we have Sierra? So the purpose of Sierra is simply that Sierra, it wants to make sure that it's safe. There means that it is not possible for you to have a Cairo program that is going to panic. You know, if you are writing a Rust program or even JavaScript program, there are possibilities of, for you to have different kinds of error that it can result into panic, that your program can just return error. But with this, it means that when you write a Cairo program in a programming language that is, human friendly, like the Cairo, when you write a Cairo program, now it is not, you have to convert it first to Sierra. So when you convert it to Sierra, if you successfully convert it to Sierra, it means that it is not possible for that program to fail. It's not possible for that program to fail. So that's which means that for any input, there is going to be an output. For any input, there is going to be an output. Then the Sierra is now converted to what? To Kazim, which is the Cairo assembly language. So since the Sierra is safe, then it means that the assembly language that is generated from the Sierra is also safe. So that is just about the compilation. So that particular part of it is just about the compilation. Now, at the other part of what's it called? At the other part of the Cairo also. So for that part of it, it is not possible for your Sierra code. It cannot panic or anything. So when you now convert from Sierra to Kazim, then at the Kazim level, Kazim is simply an assembly language which then performs whatever it is that you want to do. Then we now have we now have the other one. When you've already like compared it to, you already have the Kazim there. So if you are going to be running it, then whatever computation that you are performing on it is going to generate a proof for it. So it is now possible, if you have deployed a contract, then it is possible for people to run they might want to like run a program, and it is possible for it to fail then. But when you compile your program from the high level language to casting, it is not possible for it to what it is not possible for it to fail. So that's the main purpose of Cairo. So it is for normal CPU architecture, the major problem that people usually look into is the ultimate problem. And the ultimate problem, we know that's also one of the things that resulted into what gas metering of solidity and layer one. So, but for Cairo, it is not only ultra problem that you are looking at, you are also looking at what panic. So a Cairo program, it cannot panic when you've converted it into what? Into Sierra. So which means that when you are writing your code, if there is any possibility of it to panic, it is not going to compile. So you need to first understand that it is not to what it is not going to compile into Sierra. And yes, uh, and the programming language also that we are also making use of, it is also optimized in such a way that the proofs that are generated from it has already been optimized. So using int, so those ones are the low level aspect of the Cairo that we are not so interested about at this point. So what we are going to be doing now is we are going to be looking at, okay, how do we write a Cairo program? How do we write a Cairo program? So the number one thing that we need to understand is that Cairo programs, their syntax is Rust inspired. I mean, by Cairo 1 programs, their syntax is Rust inspired. So it doesn't mean that you can do everything that you do in Rust, that you can do it in Cairo. That's not the case. Because for all the things that you are going to be making use of in Cairo, they are already associated with some ints because they are compiled to Sierra. So you need to understand that when you write Rust, it is possible for you to compile your Rust down to maybe bytecode or LLVM or different kinds of targets. So, but for Cairo, your target is what is Sierra, and you can only make use of what has been predefined. So we are going to be going through the Cairo book to learn how to how to write a Cairo program. So of course, if you want to, I believe every one of us here, installed the we already have Cairo on our system, right? Is there anyone that hasn't installed Cairo? Okay. So since all of us we have installed Cairo on our system, and we also have it's just like Rust. In Rust, you have Rust as the programming language, then you have the package manager, which is the crate. So in Cairo, you have Cairo as the programming language, and you also have the package manager, which is the scarp. So we are going to be looking at how to write. So let's first just check out how do we even how do we write how does writing Cairo programming language, how does it look like? How does Cairo look like? How does Kazim look like? And all of those stuff. Okay. Okay, so I actually need to set the what's it called up. All right. So before we go, like while I'm trying to set it up, does anyone have any question? Maybe what I'm doing is not clear yet. Does anyone have any question as regards Cairo? We all understand Cairo now. Why we are writing Cairo, right? That's great.
I have a question.
Good.
Can you hear
Okay.
me?
Yes, I can hear you.
Okay, so you were talking about how it's like when we're writing Cairo code, it comes from the Cairo high level language, then down to Sierra, then to
Yes.
Cousin. So like from that Sierra to Cousin, so you explained something that I did actually catch. So if you can just, rephrase like why do we need to go from Sierra? Why not just go down directly to Cousin?
All right. So in the Cairo zero version, when you're writing in Python, you can write your Cairo program and it goes directly into Kazin, right? But for Cairo 1, so I said that the meaning of Sierra is safe intermediate representation, right? So the word safe there, it means that it's it makes sure that whatever program what you have written in that high level Cairo programming language, it cannot panic. Do you understand the meaning of panic? So panic is anything that can make your program to stop at the mid in the middle. You get anything that can make your program to stop in the middle. So if you write systems programming language, there are some times that you just be running your program and it's going to reach a particular whatever kind of error. It will reach some kind of error that you just panic and it will stop. It's just like maybe you are writing JavaScript and there is a runtime error. There's a runtime error and let me say compile time error and it stops. Uh, so something like that. So converting to Sierra, it means that it is safe. So from Sierra to Kazim now means that whatever that particular Cairo code, it simply means that it's not panic. That's just the simple meaning. It cannot panic.
Okay, so I'm going to refer to Solidity because that's what I know, right? So why didn't we need Sierra for Solidity?
Okay, for solidity, you what you are so there is difference between so there is difference between the way solidity and Cairo works, right? In solidity, you are running solidity on EVM, which is Ethereum Virtual Machine, and EVM it's just the same normal CPU model. So the normal CPU model is you read, write, and all of those stuff. Like it's reads from memory, write to memory, and all of those stuff. But for Cairo, it is different. So for Cairo is proof of computation. Cairo is proof of computation in the sense that what you are
Victoria, hello. Yeah, I'm getting it now.
He's having
Okay.
network issues.
Okay.
I hope everyone can hear me. Mm.
Hello, we were not hearing you initially, yeah, but we can hear
Okay,
you now.
so actually, I'm just back now. Okay, how about now?
Yes, sir, we can hear you.
All right, thank you. So I'm saying that there's difference between Solidity and Cairo. The difference is that we use Solidity. Solidity is used on EVM, right? So which means that Solidity is just like the normal programming languages. It's similar to the normal programming languages, and it runs on the normal CPU. So a normal CPU, it can read from memory, it can write to memory, right? So that's how the normal CPU works. So which means that Solidity, you just convert it into what? Into bytecode. When you write your program in Solidity, it is compiled into bytecode. And that bytecode is run on the EVM, right? Now, there is now Cairo. Cairo is for StackNet, or Cairo is used for ZK proof. Now, when you are making use of ZK proof, so you make use of ZK proof or zero knowledge proof for either to achieve two things, either to achieve privacy or to achieve what? Scalability. Hmm? So when you make use of for scalability, it just allows you to perform computation on a big system. Let's say that you have two systems. You have a computer and you have a phone. Now, you want to perform a computation on your system. You cannot perform that computation on your phone because maybe your phone has 2 MB RAM, but your system has 1 TB RAM. So which means that you can perform that computation on your system. However, you cannot perform it on your phone. So you want to be able to perform this computation on your system, then prove that you correctly performed it on your system on your phone. So proving is different from what? So for you to be able to generate that proof, you will need, all those ZK protocols. That's where that Cairo comes in. And the way Cairo CPU model works It is different from the way the normal CPU model works. So for the normal CPU model, it is read write. You can read in the memory and you can also write into memory. However, for Cairo, it is a read only model, which means that you don't write. It is a read only model, which means that you don't write. And also, it is proof of computation. So which means that when you run a Cairo program, the way it processes it is different from the way normal CPU processes it. So that's the reason uh, for Cairo you have to convert to Sierra first, then convert it into Kazim. But for Solidity, from you just convert it to bytecode and it's going to run normally on the because whatever it is that you are doing on with the Cairo after it has run the program is going to generate a proof that the program run correctly and the output. So that output and the proof is now going to be sent into Ethereum as the settlement layer. So on Ethereum, there is a contract, there is a smart contract there that is going to take in the output and the proof, and is going to verify the proof of computation, and is going to register uh, the validity of that proof. So there is fundamental difference in the architecture of the way the two of them, the way they work. So for Cairo, you have to convert to Sierra first, then to Kazim. But for Solidity, you go straight from the programming language to uh, straight to bytecode. Yeah,
That makes sense. That makes a whole lot of sense. Thank you.
you are welcome. Any other question? Questions. Okay.
Yes, I have a question. Can you hear me?
Okay. Yes.
You mentioned that for Solidity, the EVM uses read write, but for Cario, it uses read only. So how are let's say you send a transaction now, or you are performing a computational task. How are the information saved? Are they not saved, or they after processing they are discarded?
All right. Thank you very much. So the way it works in Cairo is that there is something we call ints. There is something we call what? Ints. So the way Cairo works is that because it uses read only, it doesn't write. So it's going to int is that in some memory, it's going to assign before the Cairo program, before it starts running, it's going to write some values into those memory. So what we mean by read only, it means that when the program starts running, it doesn't change, it doesn't mutate at memory address. So it's going to provide ints in different places. So it will just read and assert that, okay, what is in this memory is what it's maybe what is in this memory. If you add it to it, what is in this memory, you are going to get what is in this memory. So there are like two things that actually occurs in a Kazim. So it's either you are asserting. So that asserting is like the write. So instead of writing into a particular memory, it's going to use int to have written into the memory already. Before the program starts already, it would have and the int would have it would have put some values in some of those memory. So it will just assert that, okay, what is in this memory is this. So that one is now equivalent to the write. Now, and the next one is going to be it can transition from one memory address to another memory address. So I hope answers the question.
Yeah, it does, but it's still a little bit confusing. Maybe it's to do more research on the.
Okay, of course, you might need to do more research for that. So if you want to, so to learn the Cairo programming language, of course, the best place is to use the Cairo book. So the best place is to use the Cairo book. And I hope everyone can see my screen.
I have a question.
Yes.
Yes, what's the question?
So if my program needs to be compiled and then comes back to Cairo to read, so does it mean the bigger the project, the more time it will take to compute, or that is not
So
an issue?
can you be more edible? Or like I cannot say it very well.
Can you hear me now?
Yes, I can hear you now.
Okay, so I'm saying if the program needs to be compiled down to because I'm like the more.
The
You
more
can't hear
what?
me well. Okay.
I can hear you now. Continue at the pace you
Okay.
were using.
Oh, okay. So I'm like the more the bigger the program, the more time it will take to be computed, or that is not an issue since
Okay,
Cairo is just doing the reading part
yes.
here.
So this is it. You know, when we talked about uh the zero knowledge and how it solves the scalability issue. So it's just like when you have your computer, you have your computer that it is very, very big. You have a computer that is very, very big, and you have a phone that is very small. Now you can perform some computation on on your computer because it has very big memory and very big processing power. So you don't really care about the size of the computation or anything. So but it's not going to generate a proof. Now that proof is going to be succinct, which means it will be small and you can easily verify it on your phone, even though your phone has a very small computational power. Now, how do we relate this with blockchain? So in layer one and layer two on Ethereum, uh, if you want to perform a transaction, you know how high the gas fee is. The gas fee on Ethereum is very high. So which means that there are lots of optimizations and different things that you have to do in order for if you want to so that swap $50, you don't have to pay maybe $70 in order to swap $50. So, however, on StackNet layer two blockchain, the layer two blockchain, now, number one, the gas fee is very. What Stacknet does is that it's going to take a lot of transaction. It will bundle them, and for all of them, it will now generate. The computational power of that one is going to be very, very big. However, we don't really care about the computational power of that one because that's like our system. Our system has enough computational power. So the one that we care more about is our phone that the computational power is small. So on StackNet, it is basically like it is more like you don't really pay for gas or anything on StackNet. You can perform whatever computation on StackNet. So it is not going to take a whole lot of computations, bundle them together, and generate a succinct proof of computation for them. Now that succinct proof of computation will now be verified on Ethereum. So so the gas fee that you are just paying there is just like after it has bundled everything together and this thing. So the gas fee is now relatively very small for the user, it's now relatively very small. If you look at it now, currently the swap cost or the for performing transactions now is now below a cent on Stacknet. So which means that gas fee is no longer a problem, or it is solving the scalability issue. You can perform loads of transactions. It's going to undo all of them, bundle them, and have the proof of computation on the uh and send the proof of computation to Ethereum, which is the base layer. I hope that answered the question. If it doesn't, I'm going to explain. All right, thank you very much. So, getting started, installation. So, if you want to run this, you should have installed Scarp, and you should have installed Scarp. So, if you should run this on your terminal to know if So if you should run this, then when it shows, the Scarp version 2.6.4, the Cairo version is 2.6.3, and the Sierra version is 1.5.0. So that's going to show you that yes, you're on the right track. So let's write hello world. So to write hello world in Cairo is actually very simple. So it's just like, if you want to write the Rust in Rust, if you want to write a program in Rust, you can simply make use of the package manager. You can use cargo new, but in this case, we are using what? Scarp. So Scarp is our package manager. So we are going to say Scarp new hello world, right? So with this now, I can now let's try to understand what is happening here. I hope everyone is with me. Is there anyone that has written Rust before here? How many people have written Rust before? Okay, nobody. It's not a problem. So if you should look at this place now, so the starting point is we have this scarp.toml, so which is like the uh, the configuration, the package configuration. So you can see in this configuration, the name of the project is Hello World, the version is 0.1.0, and the edition is this. So if we are going to have some dependencies in our project, we are going to have them here. And git ignore is simply uh, ignoring. So this what we don't want to push into our GitHub. So in this place now, we have the SRC, which is like the source, the starting point of everything. And inside it, we have the lib.cairo. So the lib.cairo is our starting point. The lib.cairo is our starting point. So if you look at this one now, in this case, we have the function, the main function is here. And in this main function, it is calling another function, which is this fib. So it's generating the Fibonacci of 6, and so this is just so, but that's not what we want to do now. What we want to do now is we want to write hello world. So how do we write hello world in Stacknet? So in this place, so it's telling us that we have the TOML, meaning Tom's obvious minimal language. So that's okay. We have the last line is the dependency. The other file created by Scrap is the src/lib.cairo. So let's delete all the content and put in the following. So we have the mode hello world, and so if you should put this mode hello world in this place, then we would have to we'll have to create another file here and call it hello world inside this same SRC. So it's going to be hello world.cairo. So then in this place, we can have function. Of course, the entry point of any programming language is what? The entry point of this particular programming language, don't let me say any, is the main. So we have function main and we have print line hello world. Now I'm going to explain something here. So we have hello? Someone's trying to say something. Who is that? Nobody.
Try to zoom in your ID. It's very tiny.
Oh, okay. How is it now?
Very, very good. Thank you.
Okay. So here we have function main print line. So this print line here, you know, in Rust we call them what? Macros. So macros are like shortcuts or shorthands for some stuff. So the folder structure that we have now, we have lib.cairo, hello world.cairo. Now there's something that I want us to understand here. Yes, the normal thing is that yes, we can write the starting point of our program is this lib.cairo. Is this lib.cairo, which means that inside this lib.cairo we can, you know, write any program that we like in this place. But if you want to use another thing, if you want to use another package, you'd have to like make a reference to them. So we call it what? Here now, this is a module. Now, if you have this lib, if you have this lib.cairo, this hello world here now, you can see that's what we are. It uses the name of this directory as the module name. So this one that is a directory, you can also make it a folder. So when you make it a folder and it is hello world, then inside the folder also you need to have the lib.cairo inside. So if you want to build, now we have two things: building and what? And running. In Rust also, in the Rust programming language, you can decide to build. So when you are building, is like you are compiling from one particular language to another. You are compiling from one particular language to another. So in this case, which is for Cairo, if you are building, it means that you are converting your Cairo programming language into what? Into Sierra. So Sierra it's going to build it into Sierra and what? And Kazim. So in that case, if you should say scab build, and we put the name of the so if you say scab build, it's going to compile what we have. So if you should look at it now, we now have this target. Now in the target we have dev and we have the Sierra code there. So this is the Sierra. This is not formatting it. So this is the Sierra of what the Sierra version of what we've written here. This hello world that we have here. So that's the Sierra version of it. And we can also run it. So if you are going to run the program, so we say what? Scab Cairo run. So when you run it, it prints what we have here, which is the hello world. So we have it in this place. So we can say this is my first Cairo program. Yeah. So you can see this is my first Cairo program. All right, so the anatomy of a Cairo program. So let's review this hello world. Now we have this FN main. So this FN simply it stands for what? Function, and main. Main is also the entry point of any function. So you see that these lines define a function named main. The main function is special. It is always the first code that runs in every executable Cairo program. Here, the first line declares a function named main that has no parameters and returns nothing. So if there were parameters, they are going to go into the parentheses. So which means that let's say that this function, we have a function that is going to take in some parameters, that is going to take in that has parameters, or that is going to take in some arguments. So inside we can have let's say another function, and let's say this is going to take name, and the name is felt. So as you're writing the name, you are putting in the what's it called? The type. So we also don't want it to return anything. So we can decide we want it, maybe we want it to return something, or we don't want it to return anything. If you want it to return something, then you need to indicate the arguments of what you want it to return. If you don't want it to return anything, it's the same thing as it is returning void. So which means you can have something like this, and in this case now we say print line, and so which means that when you have a particular name, when you pass in a name as an argument, then it's going to return that name here. So we can call that function in this place. So let's say I can put in my name here and say right. So if I should run it, what's that?
It seems help is different.
It says what?
The
Okay.
data type.
The data type, yes. Okay, yes. So the reason actually is used when you are making use of felt, you don't use double quotations. You use a single quotation.
Is it not
Wow.
supposed to be 252?
It's felt.
252. There is no 256. 252,
Felt
yeah.
252, sorry. Yeah. So this is my first programming lab. Now I'm going to return this. Let me use a debugger. Oh, so this actually, what it's returned there is, felt. No, I think it's because here we have. So felt has to be due to previous error, must be string literal. Hmm. Let's just return a bug. Oh, okay. So this what we have here is the same as this wise Mr. Musa. So the reason it is showing this way is because it has, if you want to get this, it has to be in debug mode. Now you'd remember that I said that there is the arithmetization process. So arithmetization process, it means that everything that you are seeing is converted into numbers. So the meaning of the basic data type in Cairo is what is felt 252. And what does felt 252 mean? It means it means field element. So the field element, because you know the Cairo, it has the prime number that it is making use of under the hood. So the strings and everything has to be converted into number. So this one is still in the uh, in the normal mode. That's the reason we have that. So is it that second print line calls a Cairo macro? I think I have talked about this. So if it had called a function instead, it would be entered as print line without this. So that's telling us the difference between a function and a macro. So we have a quiz here. Should we do this? So we have, what is the name of the initial function that a Cairo program runs? So what is the name of the function? Like, what is the name of
That's
whatever you tell me that I'm going to put here? What?
Main.
the
Main
Do we all
main
agree
function.
that? Or is
Yes.
master? Is it not master?
Yes, it's main. Main.
I think it's master. How many people choose main? And how many people are with me? Master. If you are with master, raise your hand. Okay, I have Abel with me. Ah. Nobody is going for master. Okay. So if you are for main, let me see your hands. Okay. It is what you people did there. Submit. Number 2, which command will run the code in your project? So which command will run the code in your project? It is scab build, right?
Scab Cairo run.
Ah. It was scab build that we used first now. What's the difference between scab build and scab Cairo run?
Scab build you only build it and convert it to serial and cousin. But scab run Cairo run will build and also run it.
Okay.
Yeah,
I
compile.
don't understand that. Okay, so let's submit. So this one is not master. Wow. Okay, so let's move to the next. Common programming concepts. So in this case, we are going to cover common programming concepts. Basically, you are going to learn about variables, basic types, functions, comments, and control flows. So these foundations will be in every Cairo program, and learning them early will give you a strong core. So variables and mutability. What's the meaning of a variable and what's the meaning of mutability? So when I said that something varies, it means it changes, right? And the meaning of mutability is just the ability of something to change, right? So that Cairo uses an immutable memory model. I think I've mentioned that. So when you hear the word immutable memory model simply means that what? The memory does not change. When you start running a memory, it does not change. Do we understand? Hey, it's like we are sleeping.
Yes, we do.
All right. So meaning that once a memory cell is written to, it can't be overwritten, but only read from. To reflect this immutable memory model, variables in Cairo are immutable by default. However, the language abstracts this model and gives you the option to to make your variables mutable. Let's explore how and why Cairo enforces immutability and how you can make your variables mutable. So when a variable is immutable, once a value is bound to a name, you can't change that value.
Yes. Well,
To illustrate this, generate a new project called variables in your Cairo project, a project directory using scarp new variables. So in our project, we are going to cd out of this and create another one. We say what? Scarp new variables. Then so now then in your new variable, so we have this in the src lib.cairo. So when you say that let x equals 5, you can print line that the value of x is this. X equals 6, the value of x is what? Is this. Let's check something. So in the src here, we are going to delete everything here. So we say let x equals 5. So here we are assigning that x, we are binding our x to 5. Then to prove that, we can just print line. So the value of x is 5. Now let us now say that, let us now make x, we are changing our x to 6. And let's check our value and say that the value of x is this again. Now we are going to run that. We are going to build that. So let's look at something. If you try to build it, scarp build. So you can see that we have an error. Now, what's the error? It says cannot assign to an immutable value. Cannot assign to what? An immutable value. What does immutable mean? It means it cannot be changed. So since this one is immutable, so we said that variables are immutable by default. The first thing is they are immutable. So which means that if you want to make it to be mutable, then you have to be explicit. And how do you make it mutable? We add the keyword mute in front of it. So adding this mute keyword in front of it is going to make it what? Mutable. So let's try that again. Okay. So in this case now, on next, okay, sorry, there's a mistake here. We are returning void, not. So if you should build it now, so let's run it. What's happening? Okay. So scarp scarp Cairo run, Abby. I'm not supposed to add this. Scarp Cairo run. So you can see that in this case, the first time the value of x is 5, and then x is now 6, which means that it has changed it. Do we understand that?
Yes.
Yes, but I have a question, please.
All right, please go on.
What, what is the importance of that print line? I don't know what is
The
doing
importance of what?
Print line. That print line.
Print line.
Yes.
Yeah, it's the one that is giving us this output here.
Okay. Okay.
It's like std out, standard output. This is a macro. Inside of it, you have the standard output. So it's because of this that we are able to see this in our terminal.
Okay.
I have a
All right.
question.
Yes.
When you're printing it, you need to pass in two parameters, or you can just pass one.
In my
When you're printing, you need to like pass that the value and like the statement and the value, or you can just pass one.
okay. So do you mean how is he able to get this X into this place, right?
I'm like,
Or
is it necessary? Is it
is it necessary
necessary? Yes.
to pass it here? Yes,
To pass
that's why I
in
did it.
two variables, or I can just pass in one. Like I can just pass x. So do I need to have something that describes the value of x?
I did not get your question.
Like when you're printing the line, can I just pass in print line x?
Oh, okay. Do you mean something like this?
No, I mean, can I do the x? Yeah, maybe, or x alone instead of like doing a whole string.
Oh, it's
Yes.
just to make it verbose, right? It's just to
Oh,
make it
okay.
verbose. It's just to make it verbose. All right, so we now know how to, make a variable mutable. Now, the next one, we have what we call constants, right? So, like immutable variables, constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables. First, you're not allowed to use mute with constants. Constants are just immutable by default. They are always immutable. Do you get? Some people are sleeping. Look at that one.
We get.
We are here. We are here.
Okay, so const keyword instead of let keyword. You make use of the const keyword instead of the let keyword. And the type of the value must be annotated. So when you want to pass a constant, you make use of the const keyword. You have to specify the, so for example, now, if I want to, let's say I want to make use of, I want to use constants. Instead of this, I'm going to say, number one is, I'm going to use const. Number two is, I cannot use mute. Number three is, I have to specify that, okay, this is unit 8 or something. I have to specify that this is unit 8. And yeah. So let's try this. It's not going to run. Or will it? Is this program going to run?
It's not going
Please
to run.
answer.
No,
Why?
no.
Why is it not going to run?
It's,
Because you already made it constant. It is,
Because
you
we
can't
made
assign
it
it.
constant. Thank you. So let's try it first. Print line unknown. Cool. What's the same? X equals 6. Like, why is x equals 6 again? It's a constant. So let's delete this. Cool. Could not compare variables due to error. What's the error? Map. Skip token expected.
So good
Oh,
afternoon.
okay.
So from what I read that const cannot be inside a function block. It should be outside of it.
Oh, so the value of x is 5. So yeah, the constant variables can be declared with any usual data type, including structs, enums, and fixed size array. So here we have const 1 hour in seconds. Yes. So one of those things also, one of those conventions is that you write constants in capitals. So you write constants in capitals. So 1 hour in seconds. This one struct instance, enum instance. So this one you can see any struct equals to this is a struct. This is an enum. This is an enum. Any you have the any struct, you have the any enum. So here this is an array. So you will see that for each of them, the data type, you have the const, the name of the variable in capitals, the data type, then that constant. So nonetheless, it's possible to use const evaluate int macro to create a constant. So this one, you can use this to create a constant. Well, the best is just to use it that way. So yeah, we want to talk about shadowing. How many of us understand what shadowing is in what is shadowing in Solidity before we move here? What's shadowing in Solidity?
He said,
What is
what's
shadowing in
shadowing?
Yes.
Okay, so so shadowing deals with the variable name, right? So it takes precedence when it is in the function block compared to when it is in the state level. So now, so when you have the same variable name in a contract, right? So the one in the function takes precedence over the one in the state. So it shadows the one in the state.
Okay. Okay. Yeah. So shadow simply means when you have functions that have the same name, right? So when you have variables that have the same name, so that's the meaning of shadowing. So yeah, they say that variable shadowing refers to the declaration of an new variable with the same name as the previous variable. So Cairo say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any use of the variable name for itself until either it itself is shadowed or the scope ends. Now let's look at what we have here. Let x equals 5. Let x equals x plus 1. You know, let me delete this. When we say let x equals 5, and we say if you say x equals to x plus 1. Now this will not go because we are reassigning x. And if you want to make this to work, we can do two things. Number one is either we can change this to a mutable variable, or we can shadow it. So shadowing means that we are going to redeclare it. Now, redeclaring it in this case means that this x that we have here, which is 5, we are now using it again here, but then assign it, it is now assigned to another thing here. So let's print line and say that the value of x here is this, and the value of x here is this, right? So what does that give us? So you can see that the value of x here is 5 and the value of x here is 6. The reason it works here is because of this let keyword. We are declaring this same name and it shadows the first one. Now, in this In this case also, when you have this curly bracket, you are declaring another scope. When you have this what's it called? You are declaring another scope. So in this scope now, we are shadowing that value again. So let's have that. So we declare a scope and we let x equals to x times 2 in this case. So the value of x in the inner scope is this, the value of x in the outer scope. Now, what do we think the value of x is going to be in this inner scope? And what do we think the value of x is going to be in the outer scope? Can someone tell us what that would be before we run it? You are sure of yourself.
The inner scope will be 12, while the outer scope will be 6.
How will it be 12? X is starting from 5.
Yes, but we still re-declared it as x is equals to 5 plus 1. So it's going to
Okay.
go into the curly bracket as 5 plus 1, that's 6. And it becomes, in the curly bracket, it's now re-declared as 6 times 2. But outside the curly bracket, it's still going to be in the parent scope because the curly bracket is more like a child scope compared to the one outside. So I think it's 12 and 6.
12 and 6. Okay, let's see. So the value of x in the inner scope is 12, and the value of x in the outer scope is 6. Thank you very much for that. Now it says that the program first binds x to a value of 5, then it creates a new variable x by repeating let x equals, taking the original value and adding 1 to it. So the value of x is then 6. Then within an inner scope created with the curly brackets, the third let statement also shadows x and creates a new variable, multiplying the previous value by 2 to give x a new value of 12. When the scope is over, the inner shadowing ends and x returns to being 6. When we run this program, we have this. So you answer that shadowing is different from marking a variable as mute because we get a compile time error if you accidentally try to reassign to this variable without using the let keyword by using let. So I think I've explained that. Okay, so we have another quiz. Who is going to take this quiz? I think maybe we should have someone to sacrifice for this next one. You are so sure of yourself. Don't go and try it before coming here. Okay, Oluwafemi Ayola, are you in this class?
Okay. Yes, sir.
Yeah, answer this question. Who wants to be a Carolinian? Which syntax creates a variable that can be reassigned? Option A, let mute x equals 99. Option B, const minute per hour equals 60. Option C, let y equals 10. The time starts now.
Let y is equal to 10.
Let y equals 10. That creates
Yes,
a
sir.
variable that can be reassigned. If you got it, it can be a 1,000, I'll be 1 millionaire. I'll be, how is it called? Who wants to be a millionaire? So that's your answer, right? That's
Yes, sir.
great. Great. Are you sure? Before we move ahead.
Yes, sir.
Is the first option, no?
Is the thank you very much. Who is that?
It's the first one, no. It's
So
the
we have
first
two
one.
people on the turntable. Who is the second person?
The first option.
Is
That
me.
was
It's the first option.
All right. We will take note of that. That you said it's the first option. So number 2, who is taking the first? Maybe you should take the first one here. Then Ayola is going to answer his own. What will be the output of this program? We have let initial equals 9, let initial equals this, and let initial equals this, and final balance is initial balance. What's the answer? The program won't compile. Final balance is 6.
Balance is 6. 6.
Okay. Ayola says 6. What's Victoria saying?
6.
6, sir.
6.
All right. So the first one, the answer is incorrect. Let y equals 10 is not correct. Let y equals 10 is not correct. Number 2, final answer is 6. So let's try.
Number one, we should
Let's
triple
try
mu.
this with your last answer. So it says that which syntax creates a variable that can be reassigned? My word. A variable that can be reassigned. Let mute x equals. So this mute here, it means that it is mutable. You get it can be changed. Okay, so let's mute x equals what? 99. Then the next one is data types, right? So data types, in normal programming language, there's something we call what data structures and algorithm. So you start with the fundamental data structures, then you build up on it. Now on Cairo, it's that every value in Cairo is of a certain data type, which tells Cairo what kind of data is being specified. So it knows how to work with that data. This section covers two subsets of data types, scalars and compound. So keep in mind that Cairo is a statically typed language, which means that it must know the types of all variables at compile time. The compiler can usually infer the desired type based on the value and its usage. In cases where many types are possible, you can use a cast method where we specify the desired output type. So let's look at this. So we have let x here is what felt 2523, and y is what unit 32. X dot try into dot unwrap. Let me copy this and try to explain what I can. Doesn't go. So we say let x, so is felt 252 equals to 3. And what? Let y. So y is unit 32 equals to x dot unwrap. Now, is this going to work? Yes. Why? Here we have 3. We are assigning 3 into what? Into x, which is felt 252. I've said something before that the basic data type on Cairo is felt 252. Felt 252 is the real data type on Cairo, which means that all those unit 8, unit 32, unit this, unit that, all of them, they are derived from felt 252. And felt 252 is also used to denote short string. And when you are using it to denote short string, what you are simply doing is you are converting that short string, into number. It will convert the short string into number. That's what it is basically doing. So let's try this. Does it work? Yes, it works. The value of y is 3. Now, in this case now we have felt 252. We want to cast. When you say cast, it's not when you say cast here, you are casting it into another thing. So the data type of this x was previously felt 252, which is big. You are now casting it into something small. So we have to use try into. We have to use try into. Try into is like if you want to convert from, let's say, unit 16 to unit 8, right? There are some possibilities where it's going to work, and there are some possibilities where it's going to fail. So when there are some possibilities where it's going to fail, that's when you use try into. But if there is no possibility for it to fail, if let's say you are converted from unit 8 to unit 16, that one you just need to use pass and it will go. Or you can just use, I think into also works. Now, scalar types. A scalar type represents a single value. Cairo has three primary scalar types: felts, integers, and booleans. So you may recognize this from other programming languages. Let's jump into how they work in. So felt type in Cairo, if you don't specify the type of a variable or argument, its type defaults to field element. When you hear the word felt, the felt stands for what? Field element. The felt stands for what? Ah, they slept.
Field elements.
Field element.
All right. So it is represented by felt 252. In the context of Cairo, when we say a field element, we mean an integer in the range of 0 lesser than or equal to x, lesser than or equal to p. We see that there is no negative value here, where p is a very large prime number currently equal to this. So this is the very large prime number that is used in Cairo. When adding, subtracting, or multiplying, if the result falls outside of the specified range of the prime number, an overflow or underflow occurs, and an appropriate multiple of p is added or subtracted. So when you say that something is a field element, there is basically no overflow or underflow actually. Okay, there is underflow or overflow actually. So, but what we mean by underflow or overflow is that when it gets beyond the largest value, the mode value, it wraps around. So let's say that the p is 5, where you get 6. Instead of writing 6, you write 1. So you have to understand how it works. So the most important difference between integers and field elements is division. So in division, that's where the problem is. So in integers, right, we have unit 8, unit 16, unit 32, unit 64, unit 128, and unit 256. U size is also unit 32. So each variant has an explicit size. So when you have this subtract 2, if you want to subtract 2 unit 8, right? If you subtract 2 unit 8, you get at most unit 8. So all integer types previously mentioned fit into felt 252 except unit 256, which needs 4 more bits to be sorted. Under the hood, in 256 is basically a struct with 2 fields. So you have 2 with low and high. So Cairo also provides support for signed integers, so which is the I. These integers can represent both positive and negative values with sizes ranging from I8 to I128. Each signed variant can store between this and this, where n is the number of bits I want to use. So you can write integer literals in any of the forms shown. Note that numbers literal that can be multiple numeric types allow a type suffix. So if you have 57, you can have type suffix. So this will specify. So let's say let's look at something in our so if I say let x equals to 5, in this case now, the data type of my x is felt because I did not specify. So if I want to make it to be a unit 8 now, you see, I just have to do this. Now let me do something here. Is this possible? So let's see if this is going to run. You can see it does not run because that value is more than unit 8. Variables, we have passed this. So data types. So we've talked about that. So numerical operations. Numerical operations, we have. Before.
Sorry, I have a question.
Yes. What's that?
Can you expand more on the differences between division and subtraction and computation?
Okay. The difference between division in a field element and an integer is that for a field element, hmm, for a field element, when you divide two numbers, you are going to get another field element. When you divide two numbers, you are going to get that one it's a bit of mathematics. Like if I start explaining it might get more confusing. So for example, let's say, and firstly, if you want to, you need to firstly understand what is even the meaning of a field element. So for you to understand what a field element is, listen to the things that you need to understand what there are some things that we call what's it called itself. So we start from a group. Is it even a group that we start from? Yes, we start from we have what we call morphemes, we have group, we have magma, semi-group, then we have field. So when you now get to a field, so a field element, listen, number one, a field element is an element that when you have sorry, we start from structure. A field structure, uh it has some binary operations. It is closed, it is associative, it has inverse element, it has identity element. So when you have all of that, then you now have, for a field element, you need two this thing. You have it over two operations. So for the other one also, it has identity, inverse, and field elements. Inverse and it has identity element, inverse element, and it's also closed. So when you have that, then you can have a field element. So for a field element, for example, now, if I'm doing for a field element, it's going to mostly be in a prime number. Like you have to be it has to be to the modulus of a prime number. So let's say that we are taking a prime number of 7. So if I ask you that what is 2 which is a field element in prime 7, and 7 and 5. So if I ask you that what is 2 divided by 5? In that case, what is 2 divided by 5? So it might require some calculation for you to get it. So in that case now, 2 divided by 5 is going to most likely be it will require some calculations for me to get it. But 2 divided by 5 for integers, in fact, not even integers now. For a real number, 2 divided by 5 for integers, it does not have a value. 2 divided by 5 for integers does not have a value. For real numbers, 2 divided by 5 is going to be 0.4 for real numbers. So I don't want to explain it too much so it will not get too confusing. But if you need the explanation, maybe later, or you can read more on it actually. So numerical sum, you can sum two numbers, 5 plus 10. Get difference, subtract, multiplication, times, division. So the division here is called, this one is quotient, and this one is called what? Order. Right? So each expression in these statements uses a mathematical operators and evaluates a single value. So the Boolean type, we have f of n function main let t equals to true. We have the true, so it can either be true or false. So string types. So string types, we have short string. So they are telling us that a short string is ASCII string where each character is encoded on 1 byte. So this one represents this one represents this. So Cairo uses FEL 252 for short strings, as the FEL 252 is on 251 bits. So a short string is limited to 31 characters. So, and you can also see that you use just one quote. You don't use double quotes to represent string literal. So byte string. So this one is a byte string, long string byte string. With the byte string structs added. Typecasting. Typecasting is simply moving from one type to another. Like when you're moving from one type, you want to move a variable from one particular type to another type. That's typecasting. So let's see what's happening here. So if you have a felt 252, I want to convert it to unit 8. So you know that all of them, they are still numbers. So you can actually like convert. So but in this case now, we use try into. You use try into when you are converting from an higher to a lower. Do you get? From an higher to a lower. And there is possibility of what? Of error. So that's why you put this on wrap. But you can handle the error better later. We'll talk about it. How to handle the error better later. So the next one we have from unit 8 to unit 16. You can see that this is from lower to higher. So you just use into, and that goes from higher to lower, and from lower to higher into, lower to higher into, lower to higher into. This one felt for 252 is actually lower than unit 256. So you use into. So this one is bigger than this. So you use try into and use unwrap, or you can handle the error better. So we also have the tuple. So the tuple is just like an ordered list of elements. So you can specify, you can see here you can have it as a compound data type. So you have unit 2, unit 2, unit 4, and the bool like that. And one good thing is also you can destructure a tuple. You can destructure a tuple element. So here x will be equal to 500, y will be equal to 6, and z will be equal to true, as you can see here. So then the unit data type. So the unit data type is also like the nothing. The unit data type is a type which has only one value. So this unit data type that is here, you might not understand why it is called unit very well right now. But just understand that yes, this is called unit data type. And you can also call it what void. So you use it to represent when something is returning nothing. So we have the quiz. Who wants to be a millionaire? So he's going to be taking this quiz session first. All right, is Daniel here? Daniel. Okay, he's not here. He has slept. How about Aguala? Aguala Joshua. Okay, can someone volunteer? Someone that hasn't done before. Okay, Mary wants to be a millionaire. Let's start. Question number 1. The largest number represented by the type I128 is what?
I'd say B.
Is what?
B.
What?
The last option. 2
The
and
last
7 minus 1. Yeah.
2 raised to the power 127 minus 1. Okay.
Yeah.
What will happen when computing x minus 1? What's the answer?
I'd say it would panic.
It will always, this one, Abby.
Yeah.
Okay. Determine whether the program will pass the compiler or not. So look at this. Will it pass? Does it compile?
Yeah, it will compile.
What does it return? What will it print in this? STD out. 2. Are you sure?
Yeah.
Okay. So the first one you are correct, the second one you are correct, but the last one, the program does compile is wrong. Why?
You should return X.
It should return X. Why? The program is not going to compile. That's just the answer.
Why would it compile? Why
The
does it
program is not
compile?
compile. The program will not compile. So is that this type
There's nothing like that.
32 does not exist. It's just a felt 32. It is felt 252, not 32.
Okay.
Then we have function. So functions are prevalent in Cairo code. You've make case as the concept like that. So we define a function in Cairo by entering fn, followed by a function name and set of parentheses. The curly brackets tell the compiler where the function body begins and ends. So you can call any function we've defined by entering its name, followed by a set of parentheses, because another function is defined in the program. It can be called from inside the main function. Note that we defined another function before the main function in the source code. You could have defined it after as well. Cairo doesn't care where you define your functions, only that they are defined somewhere in the scope that can be seen by the caller. So let's start a new project with scarf named functions. So we don't really need to start another project, but let's just call another function like this. So we can actually just write, how do we start a function? Fn, right? Another
Yes.
what? Function. So, but in this function, we want to take in an argument. So we are going to take in an argument of 252, right? And we are going to, let's just show it here. Wow. So we can call this function in this place. So another function like this, right? And run it. So from this main, it calls this function outside here. So I know we know how to call functions already. Then now in a function, we have two types of functions. We have what we call a statement and an expression, right? So function bodies are made up of a series of statements, optionally ending in an expression. A series of statements optionally ending in an expression. Answer that so far, the functions we've covered haven't included an ending expression, but you have seen an expression as part of a statement. So a statement is, when you can have two expressions that are connected together. So that's a statement. So for example, an equation is a statement that shows that two or more expressions are equal. For you to know, that's like a statement. So when you have more than one expression connected together, that's a statement. So because Cairo is an expression-based language, this is an important distinction to understand. So statements are instructions that perform some actions and do not return a value. Expressions that evaluate with resultant value. Let's look at some examples. If you have this function, let y equals to 6. So it's saying that function definition are also statements. The entire preceding example is a statement itself. So this let x equals to let y equals to 6. So this let y equals to 6 here, it makes y equals to 6. So it now say that let x equals to that y. So when you run this program, you say that it is missing a token. So it's missing a terminal token. So unused variable, unused, the y is not used. Okay. Let y equals to 6 statement does not return the value. So there isn't anything for x to bind to. So it is different from what happens in other languages such as C and Ruby. So let x equals to y equals 6. Have both x and y have the value 6. That is not the case in what? In Cairo. So in this case now we say let y equals to this. This is an expression. This is a statement. This is an expression. So this expression x plus 1 is returned. So y will now be equal to x plus 1, which is 4. So the value of y here will be equal to 4. So functions with return values, whenever you have a function that returns anything, you have the data type of what is returned. So we have a quiz again. Who wants to be a millionaire? Who is volunteering? Anybody? Nobody. Okay, we have Bolaji Mubarak. Is he here? Bolaji Mubarak. Ah, he's sleeping. Matthew. Ajayi Matthew. Matthew Ajayi. Okay, can someone who is online actually volunteer? Nobody. Okay, Abel. Did I get the spelling? Abi, did I get the pronunciation right? The keyword for declaring a new function in Cairo is what? What's the keyword?
FN.
Is that Abel?
Yes.
All right. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. Is it going to pass? And if it passes, what's going to be the output?
0.
The first question, will it compile?
Yes, it passes. It compiles.
And it returns 0. I hope you did not test it.
No, I'm looking
In
at
Cairo,
it.
a curly brace block like this is what? When you have a curly brace like this, you know what a curly brace is?
Yes. It's a statement.
It's a
A
statement.
statement.
A statement. That's 2, right?
Okay, wait. Okay, 2, 1 and 2. There's no 1 and 2.
1 and 2. Are you sure? There's no 1 and 2. So
Let's go for 2 only.
2 only. A statement. Okay. Number 4, determine whether the program will pass the compiler. If it passes, write the expected output. Is this going to pass?
I don't think this. I don't know. I'm not sure this is supposed to pass.
So it does not compile. The first one, FN, correct. The next one, the program does compile. So the program is not going to compile. Why? The program is not going to compile.
One.
I think it's because of line one. Like the way you were doing it before, where you were adding like X, then colon, the type U or something. I think
Yes.
that's the
You're
reason.
supposed to put the type of this X. So what's the type of this X? So it's not going to compile. But you're putting you're supposed to put the type. The next one, this it is a statement. Hmm? It is not Abi. This is incorrect. It's not a statement. This is a scope. No, but it is not three. There is no three only there. So it can be a returned expression also. Determine whether the program will pass the compiler. This is going to is going to is going to pass. So it's an expression and it's syntactic uh, scope. Yeah. So the program will compile and it will return three. So it does not compile. So the reason is because of the parameters. It needs an argument. Okay, so comment is very simple. This is how you comment. It's similar to multi-line comments. You can also comment this way. You can also comment this way, right? So what is the syntax for introducing comments? It's like this, right? What's the
No,
syntax for introducing comments? It's hash. Like, what's it?
Forward slash.
Apostrophe and hash.
Hey. Apostrophe. All right. So control flow. So the ability to run some code depending on whether a condition happens. So that's the control flow. So the if expression, look at so in the if expression here, you just have if you are not putting you have if then the condition. And number one is that the condition must return true, like it must return true. You cannot, in JavaScript, you can just do if number. No, it must return a boolean. So if number is equivalent to 5, not if number. Do this, else this. You also have the else if. So look at this one now. Is this going to compile? Let's check. If you should run this, uh, so it's not compiling. So this one you have to say if this equals to 3, then it runs successfully. All right. So handling multiple conditions, else if. So if, else if, then else. Then we also have if in let. So you can say let number equals to if condition. So which means that the return value of this thing, you are assigning it into this number. And we have the repetition with loop. So you can have loop here. You loop. When you have this loop, it will continue unless you have a break value. So we have the loop. You can also return values from loop. So let result equals to. Then we have the conditional loop, which is the while this is greater than this. So please, let's just take it. So determine whether the program will pass the compiler. If it passes right the expected. So if you look at this, let x equals y, let y equal x. Now the problem here is what x what you need when you are making use of the if, you need it to return data type here. is unit, not boolean. So it's not going to compile. What happens in Cairo if an if condition evaluates to true, the program skips the if block. So the program executes the block of code associated with the if. So the two, and this is the convention. What is the result of running a Cairo program with an if statement where the condition evaluates to false and no else block is provided? When it returns to false and no, so the program panics, no. The program executes and it no. Stop the execution, skips it. So the what feature does Cairo provide to repeat until a specified condition met or else runs out? So use loop or while. So you people should clap for me now. I cannot hear. Thank you. So the next one we have the common collections. So when you hear common collections in programming language, what you are referring to are arrays, right? Collections is all those linked lists, array, all those ones. So Cairo provides a set of common collections type that can be used to store and manipulate data. So these collections are designed to be efficient. So we have two, arrays and dictionaries. So an array is a collection of elements of the same type. You can create and use array methods by using the array traits from the core library. An important thing to note is that arrays have limited modification options. Arrays are in fact queues. Do you know the meaning of queue? What's the meaning of queue? Can anyone explain the meaning of queue here? Or most of you don't. Yeah, usually.
Okay, queue.
Yes. What's queue?
Queue is just like first in, first out.
Queue.
Yes.
So first in, first out. But maybe that doesn't work in Nigeria. So when you're in the queue, if you are the first person on the queue, you'll be the first person to be attended to. So we have queue, we have stack. Stack means what? First in, last out. So whose values can't be modified? This has to do with the fact that once the memory slot is written to, it cannot be overwritten, but only read from. You can only append items to the end of an array and remove items from the front. So creating an array is done with the array trait new. Here's an example. So you have let's mute. This mute, it means that you can modify it. A dot append, you are appending 0, appending 1. So when required, you can pass the expected type. You can pass the expected type. Updating an array, a dot append. You can use append to update it. When you want to remove from it, use pop front. So use pop. When you use this pop front, there are two possibilities. It returns an option. So option means it can either give you a sum. Like when you use option, the option is just an enum with some value, and so sum means that it has something in it, and none means it has nothing. So when you use this unwrap, it means that you should panic if there is nothing inside it. So the above code will print the first value of this is 10. So reading elements from an array. So you can get to access array elements, you can use get or at. So using array.at_index is equivalent to using the substitution this. So these two are the same. The get method. For the get method, the get function returns options with the box pointing to the reference, which means it returns an option to a box type, Kairos mouse pointer, containing a snapshot to the element at the specified index. If that element exists in the array, if the element doesn't exist, get returns none. This method is useful when you expect to access indices that may not be within the array's bound and wants to handle such cases gracefully without panic. So we have let mutable this equals this, let index to access you have one. Mash array dot get, you have when it is sum, when it returns sum. Now this mash, we have not talked about it. Use mash to handle different return values. So since we know that this array dot get is going to return sum or none, so this mash is going to help us when it returns some value, it should give us this, but if it returns none, then it should do this. So we've talked about the art. It's going to return as a particular distance. Then we have the array macro. This array macro is going to, instead of writing array trait new, array append one, append two, append three, you can make use of this macro to get value. So storing multiple types with enums. So you can make use of enum to store different types. We have data, we have integer, felt, tuple, like that. Now, these things that we have here, they are also what? They are also macro. This thing that we have here, they are also macro. So it's going to implement copy and drop. We still talk about um, traits and generics. So we also have span. Span is a struct that represents a snapshot of an array. It is designed to provide safe and controlled access to the elements of an array without modifying the original array. So span is particularly useful for ensuring data integrity and avoiding borrowing issues when passing arrays between functions or when performing read-only operations as introduced in reference and snapshots. So all methods provided by array can also be used with snap and span, except for the append method. So to create a span, you call the span. So yeah, which call to the find util function will cause a runtime panic. So we have this mutable v span this. So we know that from span here, it's designed to save and control access to this thing without modifying the original array. Span is particularly useful for ensuring data integrity and avoiding borrowing issues when passing arrays between functions. So which means that anything that requires what's it called? Mutability. So find util and let mute I equals to 0. Let mute I equals to 0. Then you loop from if I to till break. If I equals to till, else this. So in this case now, it is starting from it's going to start from it's n is 3, till is 3. What is n? So since we have three things here, this one will most likely give a let me just choose this. Determine whether the program will pass the compiler. So this is an array you're accessing at 0 fs s dot append. So this one now is a snapshot. It shouldn't pass. Determine whether the wait, yeah, that could have meant the referencing. Determine whether the program will pass the compiler. This mute this I plus or equal to 1. does not compile. Some compiles. Okay. Oh, it's the last one. If 2 equals to 4, then for an array of like 3, because it returns 4. Okay. This, it does not compile. Ah. Then we have the dictionary also. So dictionary is just like the map in JavaScript. So you can insert, so you insert this into this. You can also get the value. So stuff like that. Discussion dictionary, entry and finalize. Let's talk about the ownership model. So understanding Cairo's ownership system. Now, Cairo is a language built around a linear type system that allows us to statically ensure that in every Cairo program, a value is used exactly once. So this linear type system helps prevent runtime errors by ensuring that operations that could cause such errors, such as writing twice to a memory, are detected at compile time. This is achieved by implementing an ownership system and forbidding copying and dropping values by default. So that Cairo uses a linear type system. In such a type system, any value must be used and only be used once. Use there means that the value is either destroyed or moved. So destruction can happen in several ways. A variable goes out of scope, a struct is destructured, explicit destruction using destruct. So moving a value simply means passing that value to another function. So when you pass a value from one place to another function, it means that you have moved the value. So this results in somewhat similar constraints to the Rust ownership model, but there are some differences. In particular, the Rust ownership model exists in part to avoid data races and concurrent mutable access to the memory. But this is obviously impossible in Cairo since the memory is immutable. Instead, the Cairo leverages its linear type system for two main purposes: ensuring that all code is provable and thus verifiable, abstracting away the immutable memory of the Cairo VM. So, ownership. In Cairo, ownership applies to variables and not to values. Ownership applies to variables and not to values. A value can safely be referred to by many different variables, even if they are mutable variables, as the value itself is always immutable. Variables, however, can be immutable. So the compiler must ensure that constant variables aren't accidentally modified by the programmer. This makes it possible to talk about ownership of a variable. The owner is the code that can read and write if mutable. So that means that variables, not values, follow similar rules to Rust. Number one, each variable in Cairo has an owner. Each variable in Cairo has an owner. So the owner is usually the what? The scope. There can only be one owner at a time. There can only be one owner at a time. So which means that when you move out of a scope, when you move to a different scope, you move the owner. So when the owner goes out of scope, the variable is destroyed. So when the owner is destroyed, the variable is destroyed. So now that we are past basic characters, that we want to include all this, okay, you understand. So in this case now, when you say that let x equals to what? Hello, right? Now, if you have, let's write this for our own so that we can follow it along. So here we have fn main. So we say let s equal to hello, right? So in this case now, this variable s, the owner of this variable s is this scope, this main scope. Now, I know that the variable s refers to a chosen. The variable is valid from the point at which it is declared until the end of this correct. So, where does this? It is valid from this place up to the end here, up to the end here, which means that anything, if you should, from this place now, if you should say print line and you put x here, it is not going to work. Because number one, the s is not even used there, then it is already out of scope at this point. Right? Ownership. So then let's say that we now create another scope. You know, this is a scope here. Before this scope ends, we now create another scope here. And in this scope, we now say that let x equals to hello, and we do stuff with it. And then, so if we should say no, let's use another variable here. So let's say that let m equal to world. Let m equal to what? So in this place, we can print m here. But by the time we get here, let's try to print m again. But at this point, m is already out of scope. So at this point here, m is already out of scope. That's the reason we had this error. M is already out of scope. So a variable and scope in which it is valid. In other words, there are two important points here. When x comes into scope, it is valid. It is when valid until it goes out of scope. So at this point, the relationship between scope and when variables are valid is similar to that in other programming language. Now we build on top of this understanding by using the array type introduced in the previous one. So let's say that moving values, we have let immutable this equals to this, we have this, then array dot append one, we append 1 and 2. So here we now have a function here. We are going to write that. So we have let mutable array equals to, we are creating a array of unit 1 to 8 elements equals. Okay, so this is going to like give us a, so let's push some values. Now in this case, we now have, how does the type system ensure that the Cairo program never tries to write the same memory to? So we already have this full array. So we have a function here. So if I should try to, so okay, before that, I'm going to print. I'm going to print this. Now, before and after, right? So in this place now, we know our array. This is our array here, right? So I'm going to print. I'm going to print it here. After printing it, then we are passing that array into this function, which is another scope. Then we are going to try to print it again. Now, we have an error. Why do we have this error? Wait. Okay. Oh, we are supposed to use the. Wait, isn't oh, we are using. Is it push? It's push now. Oh, it's a pen, not push. Okay, so in this place now, we have array.pop front. We so in this case now, in the first instance, it's actually possible that it has even moved it in this print line. It moves in that case also. Oh, okay. Does you should implement debug now. Yeah. Yes. So this is what I'm looking at. This is the order I'm looking for. So here we have Onado must use. So you see that variable was previously moved here. In fact, it did not even get to this place. So from here, it has already moved this array. From here, it has moved this array. It moved it from here to here. So which means by the time you are calling it here, there is nothing left. So assuming it did not even move it here, maybe it moved it here. So when it is getting out of this print line, it is out of scope already. So which means that this array here is nothing. So that's the ownership model. So I'm going to delete this. So which means that yes, it entered this first case. But now let's try to like pass it in 2 times. So saying that was variable was previously moved. So which means that in this case now it moved it. There was movement. How is there a movement? We have an array. So it was declared there, which means it's supposed to be valid from here to here. However, when it got to this place, it was moved to another scope. This is another scope here. So when it was moved to another scope, the scope ended here. So coming back to this place, there's no array again. Coming back to that place, there's no array. So yeah, so one of the ways in which we can, get away with that is when we are moving something, when we are moving from one function to another, when we are moving from a school to another, if that data type, if it implements the copy trait, then it's not going to move. It's going to simply copy it. It's going to simply copy it. So an example is if you should have this struct. So I'm going to use let me copy all this. I'm going to like this. So in order to, I'm going to comment this first so that we can see what is happening. So normally this is a point. So we created a point here. We moved it, we moved it here into the scope. And it has left the scope, so there is nothing remaining in this place again. So if we should try to run this code, it's going to tell us that could not compile due to previous what's the previous trait has no implementation in the context. P point. Where is P? FN full P for point. So let's just say print line. Let's see. We are going to print something different here so that so that it doesn't, we don't want it to move it beyond the fact that could not compare it to previous variable was not dropped. Oh, okay, now use the variable. So we say that no implementation for default formatter. Why? Okay. Out of the bug. No implementation. What's happening here? Oh. Okay, so the mistake actually is that the drop traits. Yeah. It's only this copy that I don't want it to have. So normally it's supposed to have the drop traits. So let me just move some. So yeah, it now has the, so you can see that it's saying that it was previously moved. So that's the error that we have now. So however, when it is moving, if it implements the copy traits, so we still talk about traits. and their meaning. So if it implements the copy traits, then it's going to run that successfully. So which means that when it is also moving, another thing that it also checks for is it checks if it implements the copy. So if it implements the copy traits, then instead of moving it, it's going to copy it. Instead of moving it, it's going to copy it. So we need to take note of that. So do we have questions while we proceed? Do you have questions? No question.
So yes, sir, I have questions. I'm so lost.
All right. Yeah, what's the question? What's the question? Someone wanted to ask a question. What?
Sorry, I said like what you did, I didn't understand. I'm sorry. Like if you can run
Uh,
through again. Sorry?
which of them?
Like this how you're doing the snapshot.
The
A snapshot is not snapshotting. I think there was a last thing you ran the snap operator.
no, we've not been to snapshots yet. Though.
Oh yeah, it is
Still
on this
talking about. I was still talking about the ownership model. Do you understand the ownership model now first?
one.
Do you understand the ownership? So the number one is that variables they have owners and they have just one owner, which is the scope in which they were declared. So which means that all variables they are valid from their point of declaration till the owner is out of scope, right? So when it moves from one scope to another, so it's going to move. So when it moves, the drop trait. So drop trait is just it's like in drop trait is just like a way of clearing the memory when you are when it is when a variable when it goes out of scope, it implements the drop trait. So the drop trait is going to clear the memory. It's like dereferencing. How is it called? You are, when you are creating a memory, when you are creating a variable, you are allocating a memory. So when you are dropping it, you are clearing, you are freeing that memory that you allocated for it. So that's what the drop trait is doing. So when you move something, it moves the ownership of the variable to another scope. And when the scope, when it ends, then it means that it's going to drop that particular variable, right? So, however, when that variable, copy, if it implements copy, then uh, instead of moving it, it's going to copy it. So, which means that when it goes out of scope, you still have that variable. You still have that variable. So So that's what they are now talking about the copy array data with clone. So if you do want to deeply copy the data of an array, you can use a common trait called clone. So return values and scope. Let's look at this. We have let A1 equals to gives ownership. So this gives ownership here is going to gives its ownership to ownership of what is returned. It gives it to A1. Now A2 now comes into scope. A3 takes the ownership of A2. No. This one, it takes the ownership of A2. This function takes and gives back. It takes the ownership of A2 and then give it back to A3. So in answer that, so yeah, A3 goes out of scope. In this place now, A3 goes out of scope and is dropped. A2 was moved. So A2 was moved to this one. So nothing happens. A1 goes out of scope and is dropped. Please, do you have question on this memory, this ownership model? Because I know that's where a lot of questions usually are, so that I can try to explain it better now. Is there any question on it again?
Yeah, question.
All right, what's that?
Okay, so when you say variable is owned, right? Is it the same thing as block scoped in like
It's the same thing
normal
as-
programming? Block scoped, like then let me say the variable is block scoped. Since the main structure is the function main in Cairo, so it's kind of like, I feel like it's kind of the same logic when you say a variable is block scoped, like it can only be accessed by that block or the parent block.
So I would have said yes. It is yes. However, we have different programming languages, and there are some of them that are that have garbage collectors. So by garbage collector, it means that it's when you are scoping of variables, it allocates and deallocates memory for you. So you are not the one managing it. Like in programming that paradigm, the way it is that if you are programming in programming languages like C and C++ now, you have to allocate your memory and deallocate it all by yourself. So which means that when you're bringing a variable into scope, you are allocating a memory for it. And when it is going out of scope, you are deallocating it. You have to handle it by yourself. For JavaScript or Java, they are garbage collectors. So which means that handling, when you bring a memory into space or this, all those things, it is JavaScript. It is the one that is doing everything. Like you don't think about it. So you can put something in a block scope and you are still going to be able to access it outside of the scope in JavaScript. So that's the reason I cannot say yes to your to what you said. So that's for garbage collectors. But for this one now, you are the one that you want to define the behavior. So that's the reason it now has those rules. So and the rules are very simple. When you create a variable, the variable is going to be valid till the end of that particular scope. Till the end of that particular scope. However, before the end of the scope, the variable can be moved. The variable can be what? Can be moved. So when it is moved from that scope to another scope, now in that particular scope where it is, when it finishes the scope there, it is going to be dropped in that scope. It's going to be dropped. So which means that outside of that scope, if you try to access it again, then that's going to be a null reference. You are going to be making reference to a null. Do you get? So it's like that's just simply it. This one now, this is a scope. This is a full scope. This is the main scope. The main scope started from here and it's ending here. This P1 is starting from here. Normally, it should start here and end here. However, when it got to this place, it was moved from P1 to this. So when it was moved from year to year, it means that it has its scope is now from year to year. When the scope ended here, it was dropped. So which means that P1 no longer exists here. P1 no longer exists here. Do you get? So it cannot it doesn't happen. However, I also that if this P1, if it implements copy, instead of moving it from year to year, it was copied from year to year. So which means that this one copied it. So even when it was dropped, it doesn't matter. This one again copied it. Do we get? Do you understand, Victoria?
Yes,
So,
yes, that makes sense. Abraham is asking an important question.
all right. When we implement copy trait and a variable is used in another scope and makes changes to that variable, so which value do we get back when we reference it again? The original or the changed value? So when you say that you copy something, what does it mean? You've copied it, right? So which means that it is the copied version that you are using in that other place. Do you get? So which means that the original is still, it's actually something that we can actually try out. So in this case now, so since this is we now actually there are some this thing that implements copy. Okay, this one that okay, this implements copy. So let's say that in this case now we have uh so I don't want to use something that is going to I don't want to use something that is going to like move, okay, that is going to move it again. So actually everything is just going to like it will still be 5 in this place. So let's print this first. Let's run this first. So 5 5, right? So inside this place, let's now say that when we change this P to so if we change this to P dot X, we change it to 10 here. Is it mutable? It is not mutable. So let's say that it is mutable. But so if you now change it to mutable, it's going to be another ballgame. So let's not change it to mutable yet. So let's not change it to mutable yet. But the simple this thing is that since you copied it, this P1 here is still existing here. So which means that in the next case, at this particular place, this one it was already dropped. This P1, the P1 that was inside this one, at the end of the scope here, it was already dropped. So it doesn't exist again. It is still this P1 that you are still calling in this place again. So that's the case. I hope that answers your questions, Abraham. All right. So the next one is now references and what and snapshots. So reference and snapshots. You all know what snapshot means, right? Snapshot is just like when you take a snapshot, when you camera something. So when you camera something, and when you take the picture of something, can you modify it? Ah, everyone has slept. How many minutes? Wait,
Yeah, yes.
you want not? I'm still here.
Mm.
Nobody's talking now.
Yes, sir. No, sir.
So what's the case?
You can't
So,
modify.
what's the question again?
Well, in a normal in life, when you take the snapshot of something, can you modify that thing?
Like the one I've
No,
snapped or the original?
the original, the
No, no, no.
original. No, thank you. So when you take the snapshot of something, you cannot modify the original. You just have a copy of things that you can just. So when you make reference to something, when you make reference to something, you can still change it. That's the way it works here. So for the ownership, this thing, the way it now works is for snapshot, since it is a snapshot, it means that it is not mutable. It is immutable. You cannot change it. You get, so which means that you can take 1 million snapshots of one variable. It doesn't matter. But for reference, you can only take one mutable reference and unlimited immutable reference. One mutable reference and unlimited immutable reference. So in the previous chapter, we talked about how Cairo ownership system prevents us from using a variable after we've moved it, protecting us from potentially writing twice to the same memory cell. However, it's not very convenient. Let's see how we can retain ownership of the variable in the calling function using snapshots. Using what? Snapshots. So in Cairo, a snapshot is an immutable view. It is what? Immutable view of a value that is at a certain point in time. Because that memory is immutable. So modifying a value can actually create a new memory cell. The old memory cells still exist, and snapshots are variable that refer to that old value. In this sense, snapshots are a view into the past. Hmm? Here is how you define and use a calculate length. So function. So here we have this array. Now you take the snapshot. You can see that snapshot is using at. So here now, you've appended it, you mutated this. Let first length equals to this. So the second length equals to this. Calculate using. So the length of the current when the snapshot was taken is first length. The length of the array is what? This one is just returning. So you see that in this case now, the data type, we have included this art. Whenever you see this art, it means what? Snapshots, as you are taking the snapshot. So two things, you can either have this art or ref. You can either have that art or ref. So when you are using that art, you can use it for in a lot of times. But when you are using this ref, you can only use ref once. That is the mutable. So you say that we can achieve the behavior we want in this mutable reference are actually mutable values. So the actual mutable reference are actually mutable values passed to a function that implicitly returned at the end of the function. Returning ownership to the calling context. By doing so, they allow you to mutate the value passed while keeping ownership of it by returning it automatically at the end of the execution. In Cairo, a parameter can be passed as mutable reference using the ref modifier. So in Cairo, a parameter can only be passed as mutable reference using ref modifier if the variable is declared as mutable with mute. So if you look at this one now, you can see that we have ref. We have a ref here. So, and we pass this because this variable is what is mutable here. So we pass this now. So small recap. At any given time, a variable can only have one owner. You can pass a variable by value, by snapshot, or by reference to a function. You can pass it by value, snapshot, or reference. If you pass by value, ownership of the variable is transferred to the function. You want to keep ownership of the variable and know that your function won't mutate it, you can pass it as a snapshot using at. You want to keep ownership of the variable and know that your function will mutate it, you can pass it as what? A mutable reference, ref. Do we have any question? Do you have any question as regards that?
No, sir.
Hello. Any question? No question. Actually, the way I want us to have this class is this particular one. We are going to go through. So this is like the first part of it. So the second part of it, we are going to be writing a smart contract using Cairo. We are going to be writing a proper smart contract using Cairo. So we need to learn how the things work here so that. So I believe everyone here can write smart contract in Solidity already. So we are just going to be looking at how do we convert the mental models we've developed for Solidity to writing smart contracts here. So struct. Now this struct, you can just think of it as a way of, you can call it a structure. It's like a structure. So a structure or structure, yes, is a custom data type that lets you to package together and name multiple related values that make up a meaningful group. If you're familiar with an object-oriented language, it's always like an object data attribute. In this chapter, we compare and contrast tuples with structs to build on what you already know and demonstrate where structs are a better way to group data. So we already know tuple, right? If you want to declare a tuple,
Yes,
so
sir.
you know that you have the name of the tuple, then you have all those the data types inside it. Now, but if you have a what's it called? A struct. Look at this struct now. You have struct user, active, bool, username, this and that and that. So one of those things that you can do is that let's look at this thing that we have here. Is this here. So we have this structure, user, we have active username, emails, signing and the likes. So in this place, when we want to create a user, we can say what user, we create the name of the structure and then we start assigning all of these things. Now, another thing that we now have in structure is that in structure, we can have what we call what implementations. We can have implementations of what? Of structures. So we can have using the we can have traits. Two things actually, traits. Oh no. We can have implementations. So we can implement some traits on structures. Traits are different. Traits are just like collection of behavior. So structure, you can think of structure as the body. So you can implement some behaviors on the body. So if the way we have this structure now, we can implement, let me say, I can implement user traits for user. And for this one, what I'm just going to do is, in fact, I can implement, I want to implement default. So implementing default simply means, yes. So with this default now, it means that I will be able to, let's say if I want to, I can say let's check something. Let user 3 equal to, so in this place now, I can do user default, or let's now say that if I had declared that the data type of this one is user, so I don't even need to even put user here. I can just say what default. So let's check something. We want to print line. We want to print user p. Let's see what it's going to give us. So variable, what's the question? Cannot be created from a numeric literal. Username, what's username? Oh, it's byte type. Let me change let me change them to felt. Sorry, felt 252. So what's happening? One, true. User one, user two. Trait has no default, no implementation in I'm supposed to for if I implement default for no, let me just use user. Oh, what's this? Debug. Oh, okay. I'm going to use derive debug. Yes. So all this macro that we have here, they are also would not compile due to this what unused variable, unused variable. Self type not found. Type self. So it's yeah. And just return. What's it again? Okay. Implement default. I think this one is it. This one is off that they make use of in. Let me check. Where is the Cairo break? Oh, there's no implement here. Cool. Sorry. Um, yes, okay, it's off. Maybe okay. Let's see this. So in this play, oh, I was still using default here. Even at that, still the rug is oh, this one is using not a type, not a type. Oh, invalid parts, user three, user defaults. Okay. Okay, maybe we come back to this implementation when we see it in the book. So method syntax, an example program using struct. So in this case now we have function area. No, this is not using struct yet. Okay, struct, we have rectangle. So let rectangle equals to this, area equals to area of rectangle. So this, it takes in, yes, it takes in this rectangle and produces the area. Okay, that's a good example. Another one. So method syntax. Yes. So to define method, you make use of traits. So you have traits, rectangle traits. So fn area and function area, it takes in the rectangle struct and it produces this type. Okay. So yeah, generate traits. So actually, whenever you do this, you're supposed to add this macro, generate traits. So let's use the generate traits in the following. So when we use that macro, it's going to, that's what it will use. So the one that I was doing, that one is, so you can see, yes, implement rectangle implement of this, and it's going to give you all of that. So methods with several parameters and have it too. Methods without self parameter. So yeah, methods can have two. So the ones that have self and the ones that don't have self. So for the ones that don't have self, so it means that they are what we call what constructors. They are the ones that we call constructors. But the ones that have self, those ones are methods, or is it behavior? Those ones are the constructors. So in JavaScript, there are methods and constructors. So the last very big what's it called here is the enums. So enums too, they are like enumeration. So enum, all the possible directions, you have north, east, south, west. So enumerating message, create, echo, move, like that. Implementation of enum. So then we can now, when when you use enum, you are going to list everything that is associated with it. When you list everything that is associated with it, so you can now mash. You can use mash to what, to exhaust the thing. So if you look at this message now, Abi, yes, this message. So you know that it has kids, echo, move. So you are using this match to say that if the message is quit, you should do this. If it is echo, you should do this. If it is move, you should do this. Like that. Then we also have option. Option is like an enum with some or none. So you can also use mash on this also. If it is some, you do this. If it is none, you do that. So that's that one. So the mash, we are talking about the mash control flow now. So you can see mash, the name of what you want to mash. You want to mash this. If it is this, do this. If it is this, do that. If it is this, do this. So that's, so, and in mash also you can also have multiple. This is the or operator. If it is this or this, do this. This one is for every other thing. It is either this or this, do this. For any other thing, then do this. So that's mash. Concise control flow with if let. If let. So the if let syntax lets you combine if and let into a less verbose way to handle values that match one pattern while ignoring the rest. So it's just going to match the one that handles a particular pattern. So let this equals to this, match this one. So instead of doing this, so you can just use if let this, then do this. So while let also. So then this one is just about managing your Cairo projects. That's just what this one is about. So these are the major things. These are the major things. Then package, managing your Cairo projects, we have the packages and crates. So the packages are in the scarp.toml and the associated code. So when you do scarp new my package, you are going to have something like this. And if you want to define a new module, you just use mode, whatever it is, and you start. So, and so this one is for inline, if it is inside the lib.cairo. But if it is outside it, you have to, if it is out, no, everything stays outside. If it is outside it, look at this one now, you have src garden.cairo file. This one now, you still have to declare it again in the lib.cairo file. Even though it's there, you still have to declare it. So you use the use keyword. So we have the src garden vegetables.cairo garden.cairo. So when you have this, so use the use garden vegetable. Then inside this vegetables.cairo, that's where you have this one is a struct. This is a struct there. So you can now start using it in this place. So something like that in this place also. So front of house, mode hosting, add to wait list, sit at table. So this to tell you about like how you can have a module inside another module. You can see that this module now, front of house, inside it you have two modules. You have hosting and you have serving. Inside this hosting, that's where you have these two functions. Inside this service, that's where you have all these functions. So if you want to, this is the structure. Hosting, serving, inside this you have this and this. You have this and that. So and when you want to reference also, you make use of use, then you can start from the beginning or you start from a particular place where it is known. So look at this now. This absolute part starts from restaurants. Then front of house, restaurant is the package name. Then front of house, hosting, how to wait list. This one is relative. If you are already in this place, so you can call this one straight. You start from front of the house hosting, how to wait list. So do you have any question? We are going to do you have any question?
So far, so good.
Yeah. You can Photoshop it. Yes, that's on the snapshot. But the thing is, it is when you have what we are changing is not the picture actually. It is actually the person that you snapped. So is it possible that using the picture, you're now like modifying the person's traits? So that's going to be the analogy. All right, so there is no question. So we'd have to stop here. So the exercise is basically just to read up on this number 8 generic types. So when you use generic type, how do you use it then? Error handling, testing Cairo program, and advanced Cairo feature. So like just these remaining parts. So the next class that we are going to have. So please, if you have any question, you can ask. You can ask any question that you have. So by God's grace, in the next class that we are going to have, we are going to be writing smart contracts in Cairo. So, and one of those things that I would actually also want you to do is, yeah, those contracts that you've written in Solidity before, just put them, just have them beside you. So you're going to be rewriting them in Cairo, and you'll be exploring the mental models that are used for writing smart contracts in Cairo and Solidity. So why is there no question? Is it that you people do not understand everything I've been saying, or what? Or you fully understood everything? Well, which is the case?
Okay, for me, I don't. There are some concepts that were pretty new, and it was kind of like feeling overwhelming at some point. But I'm sure if I go back and read what you've said, and probably go back and do those quizzes again, I will actually like get it more. But for now, I'm just overwhelmed.
Yeah, of course you have to do your assignments too. So that's it. I think there is enough time between now and the next class. So please and please to everyone, go through it again. And in fact, the best is the Cairo book. You can see that we are almost even done with it. These other ones, the major parts of them, you've explained them. So generic types is simple. Error handling too is simple. Testing, advanced Cairo features, and appendix. Then this smart contracts in Cairo is just like uh, all those MSD.sender, MSD.value, address this, how you are going to get all those stuff, all those stuff. That's what is here. So let's all go through it, read up on it, and everything. So that's the end of today's class. In the absence of questions and answer, then we are going to call it a day. Thank you for attending.
Thank you so much, sir.